All right, so we're going to do a practice problem on page 14 of your packet. Again, this is lesson 5, unit 2, lesson 5. So we're going to use the quadratic. So let me just read this. Solve the quadratic equation. And to do that, we're going to use that quadratic formula. Let's start by writing that quadratic formula. The x-coordinate that's a solution of our equation is equal to negative b plus or minus the square root of b squared minus 4ac, and all of that is being divided by 2 times the a value. Okay? So here I have my 3 steps for using that formula to solve an equation like this. My first step is to write the equation in standard form. Then I'm going to identify a, b, and c, and then I'm going to apply that quadratic formula and simplify. So step number 1, write in standard form. That means I need to take this 7 and I need to move it over to the other side so that all the terms are on the same side of the equal sign. But I can't just move it over as a positive 7. What I need to do is subtract it away from this side and subtract it away. We'll do the same thing to the other side. All right? These are going to cancel out to 0. That's exactly what I want to happen. And if I bring down what I have left, I end up with 2x squared plus 5x minus 7. All of that is equal to 0. So now it is in standard form because all the terms are on one side of the equal sign, and I'm meeting with my x squared, and then my x, and then my constant. So in my next step, identify a, b, and c. If I come off to the side here real quick, my a is equal to whatever number is out in front of my x squared. That's a positive 2. My b is whatever number is in front of the x. That's a positive 5. And c is whatever constant is left at the end, and that's a negative 7. Can't forget about that negative. All right? I'm just going to simply take these 3 values now, and I'm going to substitute them in to my quadratic formula. So that's step 3 up here. So that is going to look like this. I'm trying to think of the best way to do this. I'll do it in red, but I'll do it out here on the side. I'm going to start. I always like to start by just writing my quadratic formula over. So negative b plus or minus square root b squared minus 4ac over 2a. Start by actually writing out that formula, and now I can substitute in very simply with these values over here. So that's going to be x is equal to negative 5 plus or minus the square root of 5 squared minus 4 times 2 times negative 7. And all of that is over 2 times a, which is a's value is 2, so I just pop that in like that. And from this point, it's just simplifying. So I could say x is equal to negative 5 plus or minus the square root of 25 minus, if I do 4 times 2, that's 8, and 8 times a negative 7, that's going to be a negative 56, so I put that in parentheses. And that's going to be divided by 2 times 2, which is 4. So from this point, x is equal to negative 5 plus or minus the square root. I have a minus a negative becomes a positive. So I have 25 plus 56, and all of that being divided by 4. I'm running out of space here. So I'm going to pick up over here. I've got x equals -5 plus or minus the square root now of 81. All of that divided by 4. And I recognize that 81 is a perfect square, so I can simplify that. X equals -5 plus or minus 9 over 4. And at this point, I break it up into two separate equations. X equals -5 plus 9 over 4, or x equals -5 minus 9 over 4. And now I'm totally out of room, so I'll just erase these and solve these real quick. -5 plus 9 is going to be a positive 4. A positive 4 divided by 4 will be a 1. So I get x equals 1. -5 minus 9 is going to be -14. -14 divided by 4 looks like this. And I can simplify that as a fraction because they're both multiples of 2 and make that into a -7 divided by 2. Or a -7 over 2. This right here is my final answer. These are my two solutions for my original quadratic equation. So again, this was my original equation up here. If I put either of these values in for x in here, it should make this equation true. And to double check myself, I could go ahead and test that out by substituting a 1 in for x, or a -7 over 2 in for x for either, for that.